Welcome to the last lesson of this unit. All right. So in this lesson, we'll be looking at two sets of lines in some unique conditions. All right. So my original plan in the class was to have you do some investigations, but since we're doing online learning, we're going to skip the investigations, and I'm just going to talk about these two different conditions. All right. So I have two graphs here. These aren't in your notes, but you can draw a rough sketch on the side of one of your pages here. And then we'll get going with your regular set of notes. So the first condition I'm going to focus on is in this top graph here. So what do you notice with these lines? So the first condition that we're going to talk about are lines that have the same steepness. Right? Or we can say the same slope. Right? So these set of lines are called parallel lines. Right? The second condition that we're going to look at are lines, two lines that look like this. Right? And this condition is called perpendicular lines. Okay, so in this situation we have two lines, and those two lines, when they cross at 90 degrees, which we denote with a small little triangle in the corner. Right? So perpendicular lines are lines that cross at 90 degrees. Parallel lines are lines that have the same steepness or the same slope. So in this lesson, we are going to be comparing the slopes of lines in these two situations. Right? So let's put some algebra to this. All right? Right? So parallel and perpendicular lines. Right? Parallel lines are lines with the same steepness and the same slope. So if I were to give you the slope of one line, if they are parallel, the slope of the second line is going to be the same. Right? So that's a factoid that I want you to know. All right? Next is, how do we compare the slopes in perpendicular lines? Okay. So perpendicular lines are lines where they cross at 90 degrees. So when you take the slopes of those two lines, the product, in other words, when you multiply them, is equal to -1. So if I tell you the slope of one line is 1/2, and I said the second line is perpendicular to this, what is its slope? Well, what you have to figure out is what number multiplies to 1/2 to give us -1. Right? So that's one way to think of it. Another way we can think of it is the slope of one line is equal to -1 over the slope of the second line, if you're perpendicular. Okay? And this -1 over the slope is called a negative reciprocal. Okay? And we will use both of these equations depending on what the question is asking us, right? And I'll put these into context in a moment. All right? So let's go down to example 1 here. Right? So it says consider a line segment AC, so a line AC that has a slope of 3/4. Okay. Write the slope of another line, GH, which is parallel to this one. So if lines are parallel, they have the same slope. So the slope of GH is going to be the same slope of AC. So it'll be just 3/4. Okay. Now, the next question is asking us to find the slope of the line BF, which is perpendicular to our line AC. If you're perpendicular, the two slopes have to multiply to be -1, or we use the negative reciprocal. Okay? And I'll show you how the negative reciprocal works, because that comes in handy for situations where they give you the one slope. So the slope of AC is equal to 3/4. The negative reciprocal of this, so the slope of BF, what you do is you flip the numerator and the denominator, and you multiply by -1. So if AC is 3/4, BF is going to be 4/3 multiplied by -1 becomes -4/3. Right? We can check if we've done this correctly. So we can do a little check. Right? So if it's perpendicular, 3/4 times -4/3 should equal -1. So this, multiply the tops together, we have -12. Multiply the bottoms together, we have 12. This is equal to -1. So we just checked and we made sure. So if you want to find something that's perpendicular, you take the original slope, you flip the numerator and the denominator around, and you multiply by -1. Right? Right? For question number 2, I want you to pause the video, compare the slopes, and tell me if they're parallel, perpendicular, or neither. Okay, so in order to determine if something's parallel or perpendicular, we need to compare slopes. And we need to compare the fractions. And we can only compare fractions if they are in lowest terms. And hopefully you notice M2 in both of these situations were not in lowest terms, and these fractions needed to be reduced before we could do any kind of comparisons. In example A, both slopes are equal to 1/4, so hence they are parallel lines, since they're both equal to the same thing. Now, in example B, when we simplify M2 down, it becomes 7/5. Right? And comparing the two slopes, these two lines are not parallel and are not perpendicular. Right? If they were to be parallel, they have to be the exact same number, which they're not. If they're perpendicular, one number has to be the negative reciprocal of the other, which they're not. So it's 7/5, not -7/5. Right. So in the next question, we are given 2 points, P and Q here, and asked to find what would the slope of a parallel line would be for the line that has PQ, and what would be the slope of a perpendicular line compared to PQ. So in order, before we can do this, we need to determine what is the slope of PQ. So this goes back to last day's notes. So the slope of PQ is equal to y2 minus y1 divided by x2 minus x1. Right? So we'll call this x1, y1, x2, y2. So let's figure out what is the slope of PQ. So we have -2 minus so minus 7, divided by 6 minus 4. Right? So this equals, on the numerator we have negative 9, and on the denominator 6 minus 4 becomes 2. So we have negative 9 over 2. So a parallel line will have a slope of the same, so 9 over 2. A perpendicular line, example B here, will have the negative reciprocal as its slope. So we take the fraction for a slope, we flip it, so it becomes 2 over 9, and we multiply it by negative 1. So it was negative before, it becomes positive. So the slope of a perpendicular line would be simply just 2 over 9. The fourth example, it's more of an application question. It gets a little trickier here. Here we are given 3 points, L, M, and N. And we're told that these 3 points make up a triangle. And we're asked to show that it makes a right angle triangle at L. At L is meaning that 90 degrees is happening at L. How do we do this? Right? Couple different approaches, but the first thing my gut is leading me towards is just draw a sketch of this out. So we have an idea of what this triangle looks like. Right? We don't need to put the numbers exactly at the coordinates, but a rough idea. So they're saying that L is at negative 4, 2. I'll put L right here. Let's zoom this in here. L is right here at negative 4, comma 2. And they're saying M is at negative 2 and 7. So it's a little bit closer to the y-axis and definitely higher up. So I'm going to put M right here. Right? Negative 2, 7. And N is at 1, 0. So something like this right here. That would where N be 1, comma 0. Then we connect the dots up and we make our triangle. Okay. So if we want to determine if L is a right angle triangle, is this 90 degrees? Right? In other words, are these lines crossing at 90 degrees? Are they perpendicular to one another? So we need to check if the line LM and the line LN are perpendicular. So we need to find those two slopes and do our perpendicular test. Right? So our slope, apply our slope formula, right, which is y2 minus y1 over x2 minus x1, and calculate the slope of M. For the line LM, and do that find the slope for the LN line as well. So pause the video, do a little review of what we did last day, and see if you can come up with the slopes. Then we'll come back and we'll compare the two slopes and see if they are perpendicular or not. So hopefully you came up with that the slope of LM is 5 over 2. And the slope of LN is negative 2 over 5. If you made some sort of arithmetic mistake, have a look at my work here. I tried to color code all the numbers. Now to check if it's a right angle triangle or if it's perpendicular, we need to do our perpendicular test. We need to see if when we multiply the two slopes together, does it equal negative 1? So we have 5 over 2, the first slope, multiplied by the second slope, negative 2 over 5, which equals negative 10 over 10, which is equal to negative 1. Right? So now we can write a statement saying that, in fact, this is a right angle triangle because when we multiply the two slopes together is equal to minus 1. Right? So the final question we're going to do today together is example 5. Okay? And we're given two slopes of a line. One slope is -3/4. The other slope we don't know. It's k over 5. And we want to determine the value of k such that the two lines become parallel. Then do the same question again. And what value does k need to be so that the two lines are perpendicular? Right? So we simply need to apply our two definitions and then figure out the value of k. If things are parallel, they need to have the same slope. So the -3/4 needs to equal k over 5. If they are perpendicular, when we multiply the two numbers together, 3/4 times k over 5, it needs to equal -1. So now you have an equation for parallel lines, and a parallel equation for perpendicular lines. So the next job is to find out what the value is k. So you need to solve the equations. So pause the video and solve the equations and see if you can come up with the value of k needed to have parallel or perpendicular line. Okay. When solving to see if they're parallel, we cross multiply, bring the 4 up with the k, and the -3 times the 5 gives us -15 is equal to 4k. Then we solve for k by dividing by 4, and so k is equal to -15 over 4 if we want these lines to be parallel. Now it's okay that k is a fraction, right? Even though we have a fraction to begin with, and it seems like it's a weird answer, it's fine that k is a fraction, because if you would plug it in, you'd work it all out, and then you end up with this, not this odd number, but you'd have a nice even fraction there, right? So don't worry about that. In the perpendicular situation, we collect our terms and we end up with -3k is equal to over 20 is equal to -1, right? So we just need to solve for k. We bring up the 20 to the other side, then we divide by -3, and we end up with k is equal to 20 over 3. So that is it for this unit, right? Yeah, so the next unit we'll be looking at how to come up with equations of the line, and determining the slope is half the way through. Right? So next step, try the practice questions out of the homework, right, which is listed here, and do the practice quiz off of the website.